what we're going to do is we're going to find one more in general form on how to find the vertex and the zeros. Well, you never figure this out. To find the vertex of this problem, what we can do is, since it's in general form, the easiest would be, as I said before, do opposite of b over 2a. Opposite of b over 2a, if we take this, we get 3 over 2 times negative 1. And what we get right here is going to equal negative 3 halves. All right, so we have negative 3 halves is our x value. Find our y value, once again, once we get our x value, is we can plug that back in. So we have negative, we're going to have negative 3 halves, the quantity squared, minus 3 times negative 3 halves, and then we have minus 3. All right, so to figure this out, we're going to simplify this, and we have negative 9/4. We're going to have positive 9 halves minus 3. Get a common denominator. And what we then have is negative 9/4. And it's going to be plus 18 halves and minus 12/4. Okay. So putting it all together, what we can get is we got 6, and it appears to be negative. Oops, that's a 4 right there. Apologize. All right. We're going to have 6, and then we're going to have to subtract that from 9, or 9 subtracted from 6, we get negative 3/4 is going to be our other value. Okay, negative 3/4. Now, that is what our vertex is. We could also use this right here and find out what our next value is by finding it in standard form, and so on and so forth. However, we will are putting it into standard form, but we're going to just keep it with there. It's pretty fast and efficient. Next thing we're going to do is we're going to find our zeros. Now, to find the zeros, the easiest way is to factor, all right, also known as x-intercepts, just so you know. All right, but what we have right here is, I'm not sure if this is factorable. Just to make sure, I can factor out a negative, and I have x squared plus 3x plus 3. And so that equals 0, and no, it doesn't appear to be factorable. So the next thing we could do is we can use the quadratic formula. We can put it on our calculator, find the quadratic formula. And what we have right here then is going to be x equals opposite of b plus or minus the square root of b squared minus 4ac over 2a. So we're going to use that. We have x equaling opposite of b, which is negative 3, plus or minus the square root of b squared, which would be 9. And I'm looking at this. I factor out. It doesn't matter if you use those or the other ones. It'll end up being the same thing. Minus 4 times a, which is 1, times c, which is 3, all over 2 times a, which is 1. Okay? So once again, I'm using this side, factor out the negative. It doesn't matter. It will turn out to be fine either way, or you can use that. We'll get the same answer. Okay? I use this one, however. Okay, the inside of there. So when we solve this, we look through, and finding our zeros, we get negative 3 plus or minus, and now we go and we have 9, and we get 12. And we have over 2, and this is where it gets a little, we have a little pause because we're like, hey, we got negative 3 plus or minus negative 3. Well, how can that be? That's an imaginary, that'll be I squared root of 3, all right? And that is what we got right there. So what does that mean? Well, if we have an imaginary, that means that our graph must not be hitting the x-axis. And we probably could have figured it out if we would have graphed our function right here. We would have saw, okay, we plot our values. We have negative 3 halves. So we go over negative 3 halves, which will be right about here, all right, at this one point. All right, then we're going to go down over there at negative 3/4. So that's our value right there. This is our vertex. Then we're going to notice that, hey, I have a negative value, so my parabola is going to be reflected, all right, over the x-axis or the horizontal axis. So now it's going to go like this. And by knowing that, we could have saw right away that, hey, we don't have any zeros. This makes total sense. There are no zeros, so zeros, there are none, all right, because it doesn't pass through the x-axis. There are none because there are no x-intercepts. So looking at the graph, okay, verifying that algebraically, all is great stuff. but that's what we have for our answer. We can also look at this in our calculator. You take this out, all right, you can also look at it in your calculator and all those different things. And just to kind of go over how to find this on a calculator, if you would take this value, and let me just move this up here real quick like. And we have our calculator, and we punch this in our values, turn it on. We have our y equals, maybe it won't work. Oh, no. All right. It worked in a second, but you get the idea. All right. So good luck on the rest of your problems. And if there's other tutorials online if you need any extra additional help.